Subject Chemistry, first year BSc, topic Photochemistry, Session 16. The contents are photosensitization, photostationary equilibrium, singlet and triplet states, fluorescence, phosphorescence, luminescence, bioluminescence, and chemical sensors. Learning objectives are to know the meaning of photosensitization, phosphorescence, and fluorescence concepts, to know singlet and triplet states. Session outcomes: photosensitization, phosphorescence and fluorescence, singlet and triplet states. Prerequisites: should know what is absorption of light, emission of light, luminescence. Absorption of light is the light which is absorbed by the chemical reaction, and the emission of light is the light which is liberated out after the chemical reaction. Luminescence is the chemical substances which shows the light characteristics. Photosensitization. The reactant molecules do not absorb the radiation to which they are exposed and no reaction occurs. That is, when the reactant molecule exposed to the radiation, there is no any sort of reaction taking place. However, if suitable foreign substance absorbs the light and excited is added, then it passes on its energy to the reactant molecule and thereby initiates the reaction. That is, the foreign substances first absorbs the radiation from the light and it will excite to the higher energy level. Now this substance transfers some amount of energy to the reacting molecule, thereby it initiates the reaction. That is called photosensitization. This type of reaction is called photosensitized reaction and the foreign substance is called photosensitizer. That is, the foreign substance which is responsible for the photosensitivity for the particular chemical reactant. Commonly used photosensitizers are cadmium and mercury vapors. Example: the synthesis of formaldehyde from carbon monoxide and hydrogen by the photosensitization by mercury vapor. When the mixture of carbon monoxide and hydrogen and mercury vapor is exposed to UV light of wavelength 253.7 nanometer, the reaction takes place as follows. First, what happens? As I told you, photosensitizer is required. That is mercury. Mercury absorbs the radiation. It will go to excited state. That is primary step, Hg star. Now, this Hg star combines with the hydrogen. Thereby, it forms mercury. And that is mercury is separated and there is a formation of hydrogen-hydrogen free radical. That is, hydrogen molecule split up into hydrogen free radical and another hydrogen free radical. This is called energy transfer. See here, left side of the reaction, Hg star. After it is breaking the hydrogen molecule into free radical, now there is no star on the mercury. That is, the star is nothing but an energy that is given to the hydrogen molecule for the splitting. This is called energy transfer. Now, this hydrogen, one of the hydrogen free radical combines with carbon monoxide, thereby there is a formation of HCO dot. This HCO dot combines with another hydrogen, there is a formation of formaldehyde HCHO plus H dot. Now, two molecules of HCO dot gives rise to HCHO formaldehyde plus carbon monoxide. That is the one example. Second example is the action of chlorophyll in causing combination of carbon dioxide and water in sunlight to form glucose. Now, 6 molecules of carbon dioxide, 6 molecules of water and photon. Under the influence of chlorophyll, it gives you glucose plus liberation of a oxygen molecule. Here, chlorophyll absorbs light between 600 to 700 nanometer and pass into carbon dioxide and water molecules. Then, the third one is decomposition of hydrogen, ammonia, water are sensitized by mercury vapors, decomposition of oxalic acid by uranyl ion, decomposition of diazomethane by benzophenone, which acts as a photosensitizers. Photostationary equilibrium. In certain reversible reaction, at least one of them is photosensitive. The rate of forward reaction depends on the intensity of light radiation, while the rate of reverse reaction depends upon the concentration of the product formed due to photochemical reaction. A state of equilibrium is reached when rate of forward and reverse reaction becomes equal. This state is called photostationary equilibrium. It is different from thermal equilibrium. For example, dimerization of anthracene. The same topic we have discussed in the earlier session. I repeat this. C14H10, two molecules of anthracene under the absorption of a photon gives rise to C28H20. That is the overall reaction. How it is taking place exactly is anthracene absorbs photon, thereby it is undergoing activation. This activated anthracene again react with the normal anthracene, thereby it forms dianthracene. The yield should be 2, but due to thermal decomposition, yield is 0.5. Therefore, there is a decrease in the yield. Now let us see what are singlet and triplet states. In molecules, the electrons are present in different molecular orbitals. I think you know what are orbitals. S, P, D, F orbitals. The molecular states are different depending upon the spin of the electrons. The electronic states are decided by spin multiplicity, that is 2s plus 1, where S is the total spin of the electron. When compared to singlet and triplet, triplet state is more stable. Let us see how it is proved. What is singlet state then? All electrons in the molecules are spin paired. That is, the electrons are paired up. One is clockwise, the other one is anti-clockwise. It is paired. It is called singlet because there is only one possible orientation in the space. Since there is only one possible orientation, the electrons are paired. They are called as singlet state. In the triplet state, one set of electron spins is unpaired. It is not paired, it is unpaired. It is called triplet because there are 3 possible orientations in space with respect to the axis. 3 possible orientation is, it may be x-axis, y-axis or z-axis. So, the triplet, because it is containing spin of unpaired electrons, they can orient either in x-axis or in y-axis or in z-axis. So, this is the difference between singlet and triplet. Now, what is this fluorescence? Fluorescence is the emission of light by a substance that has absorbed the light or electromagnetic radiation. It is the form of luminescence. In most cases, the emitted light has a longer wavelength and therefore lower energy than the absorbed radiation. If the absorbed radiation is lesser and the wavelength of the emitted light will be greater, then they are called as fluorescence. It commences as soon as light is absorbed and ceases as soon as the incident radiation is removed. That is, the light emission will be taking place by the absorption of the photon light and it ceases. The light will put off when you put off the radiation or absorption of the radiation. This is the fluorescence. What is phosphorescence? The absorbed light is emitted after some time. The excited species remain in the excited state for few seconds and then return to the normal state. Thus, there is a time interval between the absorption and emission of radiation. This phenomenon of emission of absorbed light after some time is called phosphorescence and the substance is called phosphorescent substance, which is slightly more stable in the excited state. Even after the source of light is removed, the emission continues for some time. Here you should understand that when the light absorbs the radiation, the electrons will move from a lower level, that is ground state, to higher state. After excitement, the electron will stay there for few seconds and then it will be re-emitted back. Emission takes place. During emission, it takes some time in the excited state. After some time, it will come to the ground state. That is a time. There is a few seconds of time interval will be taking place. That is the electron which absorbs the radiation, even if it stops also, there is an emission of radiation, the emission of light taking place. That is, even after the source of the light is removed, that is absorption of light is stopped, even then the emission continues for some time in the case of the phosphorescence. That is the difference between fluorescence and phosphorescence. What is this luminescence? The production of visible radiation due to some causes other than the temperature. When electrons are excited by means other than heating, returns to the ground level by emitting some sort of radiation, luminescence is said to have occurred. The substance is said to be luminescent. Then chemiluminescence. Emission of light due to chemical change is called chemiluminescence. In a way, it is opposite to photochemical reaction. In many reactions, the products formed are in excited state which loses energy in the form of a light. Example, oxidation of the Grignard reagent exhibit greenish luminescence. Bioluminescence. If a living organism emits light due to some reaction, it is called bioluminescence. Example, the light emitted by the glowworm or firefly is due to oxidation of a protein luciferin in the presence of enzyme luciferase. That is, the protein present is luciferin protein and the enzyme is called luciferase in the glowworm or firefly. Large patch of light seen in ocean is due to marine species like jellyfish, which are also bioluminescent. Chemical sensors. A chemical sensor is a device that transforms chemical information ranging from the concentration of a specific sample component to total composition analysis into an analytical useful signal. A chemical sensor is an essential component of an analyzer. Now, recapitulation. What is photosensitization? Photostationary equilibrium, singlet and triplet state, fluorescence, phosphorescence, luminescence, bioluminescence, and also chemical sensors. Thank you.